And now let's talk about significant digits. So significant digits are really important. They confuse a lot of students because it's a new concept. But the thing is we cannot report numbers falsely. And so if our instrumentation has some sort of limitation to it, we're locked by that limitation. If I can only read something to 2 significant digits, it doesn't matter all the other measurements I take, I'm stuck to those 2 significant digits. All right, so it's important to understand significant digits. And it's also important to understand that we can't just add arbitrary zeros onto the ends of things to make the significant digits look better. All right, so to start off with, we're going to look at some numbers here, and then we're going to figure out the number of significant digits and then put them into scientific notation. If we have trailing zeros, so zeros that are not significant, they won't show up when we convert to scientific notation. All right, so this first one here, I don't have a decimal point anywhere, which means those 2 zeros on the end are considered trailing zeros and they're not significant. And so the only significant digits are that 98622. So I have 5 significant figures here. So when I convert this to scientific notation, I'm going to get 9.8622 times 10 to the 6th, okay? It's still 10 to the 6th because those 2 zeros are still there as an order of magnitude, but they're not significant, so they didn't show up in the conversion to scientific notation. All right, now this next one, I have a 0 on the end again, but I have a decimal point before that 0 occurs, which means that 0 is significant. All right, so all the digits in this number are significant, so I have 5 sig figs again. And when I convert to scientific notation, that 0 is going to show up. Okay? All right, now my next number, I have 2 different types of zeros. I have some leading zeros, and I have a 0 at the end. Now the 0 at the end and a couple of those leading zeros do both come after decimal points, but the leading zeros come after a 0 point something. So all they are placeholders for the order of magnitude. So that 0.00, those are just order of magnitude placeholders. They are not significant at all. They're leading zeros. All right, but at the very end, the 0 that comes after the 7, because 7 is a non-zero number and a decimal point appeared before 7, that 0 is significant. So I have a total of 6 significant figures here, and I'm going to get 9.26570 times 10 to the negative 3rd. Okay? Now this next one, I have 40 pounds. Or I should put I did put units in all of these. There we go. All right, I have 40 pounds. There's no decimal places there. So the only significant digit's the 4. So I have 1 sig fig, and I'm going to get 4 times 10 to the 1st as my conversion to scientific notation. Okay, this next one, all 3 of those zeros come after the 1, which comes after a decimal point, so those are all significant. So I'm going to have 7 sig figs, and I'm going to get 7.73130 times 10 to the 2nd milliliters. All right, now here I have this 800 with a decimal and nothing after it. That decimal tells me that the 2 zeros in the 800 are significant, all right, because I've got a non-zero number, a couple zeros, and a decimal point. So those zeros that are bracketed between the non-zero number and the decimal point are significant. All right, so I have 3 sig figs, and I'm going to get 8.00 times 10 to the 2nd. Okay, and then my last one, I have that 0.55. Well, so that 0 is not significant, but then that 0 in the middle where I have 309, that 0 is bracketed between 2 non-zero numbers, so it is also significant. So that one I've got 6 sig figs, and I will get 5.53092 times 10 to the negative 1st. Milliseconds, not milliliters. Okay? All right. Okay, so our non-significant zeros don't show up when we convert to scientific notation. Okay? Now let's do some calculations. So addition and subtraction, we will line up the decimal point. And so when we do addition and subtraction, we cannot keep any more significant figures than looking at decimal points. Okay, and so we're not looking at total significant figures in any one of the numbers in addition or subtraction. We're just looking at the position of the decimal point. And so the best way to do that is to line it up. All right, so I'm going to take this 39.1. Okay, plus the 124.0. So notice how I'm lining up the decimal points. Plus the 14.05. All right, so one decimal point, one decimal point. All right, so I'm going to draw a line here. That's going to let me know where I have to cut off my significant figures in this particular problem. So when I add all of those up, I am going to get 177.15. All right, so I have to round between that 1 and 5. And so there's a 5 there, so this will round to 177.2 grams. Okay, now the next two problems are multiplication and division. In multiplication and division, all we do is we look at whichever number has the smallest number of significant figures and we round to that. So I have 1, 2, 3, 4, 5, 6 sig figs here. And I have 3 sig figs here. So which is smaller, 3 or 6? 3 is. So our final answer can only have 3 significant figures. So when we do the multiplication, we get 27.9996. So 1, 2, 3. So we're going to cut it there. We're going to get 28.0. Centimeters times centimeters is centimeters squared. Okay? All right. Next one, we've got division. So here I have 3 sig figs. Here I have 2 sig figs. So what's less, 3 or 2? 2. So we'll be limited to 2 sig figs in this one. So when we do the division, we get 1.69167. So we have 2 sig figs, so we'll cut it there. So we'll get 1.7. Now milliliters divided by milliliters cancels out the milliliters. So this is a unitless answer there. Okay? All right, and then the next one is addition and subtraction again. So we're going to line it all up and look at the total number of decimal points, not total number of sig figs. All right, so I'm going to get 16.4 minus 122.61 plus 41. All right, so we're going to draw our line there because there's no decimal points in 41. So we'll do the math. We're going to get negative 65.21. We can't keep any decimal points, so our final answer will be negative 65. All right, so the deal with this stuff is this can be really confusing and it takes a lot of practice. So make sure you're doing good practice problems. Make sure when you're doing your homework, you really are putting that good faith effort in and trying to figure it out yourself instead of just turning to the internet, because it seems daunting to begin with. But once you've done it a bunch of times and once you work with it and once you get used to it, it's not quite as bad as it seems at the beginning. It's just a lot to take in all at once. And so practice with it, work with it. The more you work with it, the more you'll start to learn it as you spend more time engaging with it. All right, so that's our significant figures.